Fast food is built on trust, speed, consistency, convenience. You order, you receive, you eat. Everything feels controlled, industrial, standardized. But behind that system, there is still biology. Meat remains organic, no matter how processed, no matter how packaged, no matter how fast it is served. And where there is organic material, there is always the possibility of life. For most people, fast food feels safer than raw food because it is cooked, prepared in high-volume systems, handled through procedures. But safety in food is not determined by speed. It is determined by control. And control can fail. Not always. Not everywhere. But enough to matter. Parasites associated with meat do not come from restaurants themselves. They originate earlier, in the supply chain, inside the animal, before processing, before packaging, before cooking. One of the most well-known parasites linked to meat is Taenia asaginata, the beef tapeworm. Cattle become infected through contaminated environments. Larval cysts form inside muscle tissue. These cysts are small, often invisible during normal inspection. If meat is not cooked thoroughly, the cyst survives, and once consumed, the parasite activates. Inside the human intestine, it attaches, grows, feeds, sometimes for years. Another parasite associated with meat is Trichinella, more commonly linked to pork, but also found in wild game. The life cycle begins in muscle tissue. Encased larvae, dormant, protected. Cooking must reach sufficient temperature to destroy them. If not, they survive. And once inside the body, they migrate through the bloodstream into muscle, where they form new cysts. The body becomes part of the parasite cycle. Now consider fast food systems. High-volume production, large quantities of meat, rapid preparation. These systems rely on uniform cooking, strict timing, consistent temperature control. But even small deviations matter. Undercooking, uneven heat distribution, mechanical failure, human error. Each creates opportunity. One especially important factor is ground meat. Unlike whole cuts, ground meat combines multiple sources, which increases contamination risk. If even one portion contains parasite cysts, it spreads throughout the batch, meaning a single infected source can affect multiple servings. This is why proper cooking becomes critical. Ground meat must reach internal temperatures high enough to eliminate risk, not just on the surface, but throughout. Another unsettling reality is that parasites are not always visible. The meat may look fresh, clean, properly prepared. No difference, no signal. But biologically, something may still be present. Researchers studying foodborne parasites analyze supply chain contamination, processing methods, thermal destruction, and infection pathways, because safety depends on every stage. From farm to processing to preparation, failure at any stage creates risk. Another disturbing factor is speed. Fast food prioritizes efficiency. Orders must be fulfilled quickly. This increases pressure on cooking times, staff performance, and consistency. Under pressure, mistakes happen. Slight undercooking, incomplete heating, improper handling. Not visible, but biologically significant. One especially unsettling detail is how little is required. One viable cyst, one surviving larva. That is enough. Once inside the body, the parasite does not need large numbers. It needs opportunity. Another layer of complexity involves cross-contamination. Raw meat surfaces, utensils, preparation areas. If not properly cleaned, parasite material may transfer between food items. Even if final cooking reduces risk, early-stage contamination still matters. Historically, meat-related parasitic infections were more common. Before strict regulations, before standardized inspection, before temperature monitoring, modern systems reduced risk significantly, but they did not eliminate it. Because no system is perfect, human involvement always introduces variability. Machines fail, processes break, standards slip. Even briefly, researchers estimate millions of foodborne infections still occur globally each year. Many linked to improper cooking, contaminated sources, and handling errors. Fast food systems reduce variability, but they cannot remove biological reality. Meat is not synthetic. It comes from living organisms, and those organisms may carry microscopic life. Humans trust systems, brands, processes, but parasites respond only to conditions. If conditions allow survival, They persist. Psychologically, this creates tension. Fast food feels controlled, but underlying biology remains unpredictable. The idea that something invisible may survive within processed food challenges that perception. Another important reality is that risk varies widely. Most meals are safe. Most systems work correctly. But risk exists in probability, not certainty. And probability means occasional failure. One especially disturbing fact is how delayed symptoms may be. Exposure happens now. Effects appear later. This disconnect makes tracing the source difficult. Because the meal feels normal. No immediate consequence. Then days or weeks later, symptoms begin, and the connection becomes unclear. Researchers emphasize prevention through proper cooking temperatures, strict hygiene, supply chain monitoring, and inspection. Because eliminating parasites requires consistency, not assumption. Humans fear visible contamination, but parasites operate invisibly. They do not change taste, do not change smell, do not reveal themselves. They remain hidden until the body reacts. Perhaps the most unsettling truth is how ordinary the moment feels. You order, you eat, you move on. Nothing unusual. Then silently, something enters the body. Not detected, not expected, and the process begins. Right now, somewhere in a kitchen, meat is being cooked slightly below required temperature. Somewhere else, parasite cysts remain intact inside processed meat. And somewhere nearby, someone may already be eating a meal tonight without realizing something microscopic may still be alive inside it.